Well, hello. Here we go again. We are in day 3 of the teaching assistant strike. So we'll continue our online version of the course. I'm glad 13 of you were able to join me live tonight. So please go ahead and leave comments as you see fit. So as you can see, our lesson tonight is on double and half angle identities. So let me remind you of what those are. We have cosine of a plus b is cos A cos B minus sine A sine B. Which you want to notice for the cosine, it switches from a plus sign to a minus sign. And if you go with cosine A minus B, that's cos A cos B plus sine A sine B. We'll add that to our list again. Notice the cosine, it switches from a minus sign to a plus sign. If we go to sine, sine of A plus B is sine A cos B plus cos A sine B. I want you to notice that for the sine, if it's a plus here, it's a plus there. Same thing for minus. Sine of A minus B is sine A cos B minus cos A sine B. On our exam, I will give these to you, but I do think it's valuable to try to memorize at least these 4. I would not try to memorize a formula for tangent. They're relatively easy to derive. I did one of them in the last video. Tangent of A plus B is tangent A plus tangent B divided by 1 minus tan A tan B. And tangent of A minus B, so again, notice plus on the top, plus on the top. Tangent A minus B equals tan A minus tan B over 1 plus tan A tan B. So we'll be using these identities throughout our lecture tonight. So hopefully you have them written down. You're able to refer to them as we need them. I want to start by doing a quick proof. So let us do that. We will take a look at the following. I want to prove cos A plus B over cos A sine B equals cotangent B minus tangent A. And of A plus B over cos A sine B. So think about what your next move is going to be. We're going to make a substitution, and I hope it's obvious that what we're going to substitute is for cos A plus B. So what do we know from before? We saw that cos A plus B is cos A cos B minus sine A sine B. So let's make that substitution. Cos A cos B minus sine A sine B all over cos A sine B. Now we have a common denominator. I'm going to write that fraction, 2 fractions subtracting. So split it up into 2 fractions, we will have cos A cos B over cos A sine B minus sine A sine B over cos A sine B. And now it's a matter to see what is going to divide out. Cos A divides out cos A, and I get cos B over sine B. Minus over here, the sine B's divide out, and I have sine A over cos A. Cosine divided by sine is cotangent. So that'll give me cotangent B Sine A divided by cos A is tangent A. Let's take a look. That's our right-hand side. So equals right-hand side, and we have successfully proven that identity. So relatively easy, not a lot of choices to make. We substituted the formula for cos A plus B and then divided out, and our answer came fairly quickly to us. So the next question I want to take a look at is a very common question in trigonometry. We want to look at an exact answer for a value other than 30, 45, or 60. So let us take a look at the following. We are interested in the exact value of the sine of 15 degrees. I am going to choose to think of the sine of 45 degrees as, 15 degrees, as the sine of 45 degrees minus 30 degrees. And if we're going to do this, we have to use our sine of A plus B formula. Sine of A plus B is sine A cos B plus cos A sine B. This is going to stand in for A, and this is going to stand in for B. So if I have sine A minus B, that would be sine A cos B minus cos A sine B. And again, A is 45 degrees. That will equal sine 45 degrees, cosine 30 degrees, minus cosine of A minus cosine of 45 degrees, sine of 30 degrees. And I hope we're getting to the point now that we're starting to recognize these values. Sine of 45 degrees is 1 over the square root of 2. Cos of 30 is the same as the sine of 60, which is root 3 over 2. Cos of 45 also 1 over root 2. Sine of 30, 1/2. You might prefer root 2 over 2 instead of 1 over root 2. That is certainly fine. In fact, it might be even a little better for this example. But I tend to prefer 1 over root 2. So I have root 3 over 2 root 2 minus 1 over 2 root 2. I will make that a single fraction. And I have root 3 minus 1 over 2 root 2. So these formulas help us in a couple ways. They help us determine values for angles like 15 degrees that we couldn't have done otherwise. You could think 45 plus 30 is 75, 60 plus 45, 105, etc. So there's many, many more angles now we can find exact values for using these various properties. But our favorite thing to use with these properties is our double angle identity. So let's go ahead and recreate those. We looked at them in the last video, but we're going to look at them again. So this time I'm going to look at cosine. I'm going to let A be theta, and I'm going to let B be theta. So I have cosine of theta plus theta. What will that be? Cos theta minus sine theta, sine theta. Cos theta plus theta is cos 2 theta. Is what? Cos theta is cosine squared theta minus sine theta is sine squared theta. That's the one you want to memorize. That is our double angle identity for cosine. That has to be memorized. Now, we can also generate some other identities from that because we know we have our Pythagorean identity. Our Pythagorean identity, of course, looks a lot like this. Cos squared theta plus sine squared theta equals 1. So we can generate other identities from the double angle using this fact. For example, if I solve for cosine squared theta, let's subtract sine squared theta from both sides. Then I get cos squared theta is 1 minus sine squared theta. Then I could plug that in for cos squared theta in this identity. What this becomes then is cos 2 theta equals cos squared theta is 1 minus sine squared theta. So that replaces cos squared theta minus sine squared theta. So we get cos 2 theta is 1 minus 2 sine squared theta. So that can be a helpful thing to have. We could also do it the other way. So back to our Pythagorean identity. cos squared theta plus sine squared theta equals 1. We could subtract cosine squared theta from both sides. Then we get sine squared theta is 1 minus cos squared theta. So going back to what we have circled up here, what we have circled is cos 2 theta is cos squared theta minus sine squared theta. Now I've just substituted for sine squared theta. So I can say cos 2 theta is cos squared theta minus, what is sine squared theta? That is now 1 minus cos squared theta. What do we get? We get cos 2 theta equals cos squared theta minus 1 minus minus plus cos squared theta. So that my final version of this then becomes cos 2 theta. Cos squared plus cos squared 2, cos squared theta plus 1. So in reality, we have 3 versions of this double angle identity for cosine. Cos 2 theta is 1 minus 2 cos squared, excuse me, cos 2 theta is 1 minus 2 sine squared theta. And cos 2 theta is 2 squared theta. This is the one you want to memorize. If you memorize that one, you can always develop the other ones without too much trouble. Okay, let's do the same thing if we can for sine. So we did cos 2 theta there. You want to create an identity for sine of 2 theta. So here I started cos theta plus theta. On my next page, I will go to sine theta plus theta. So if that's the case, I am now using this formula. Sine of A plus B is sine A cos B plus cos A sine B. So I'm going to go to sine of theta plus theta, which is sine theta cos theta plus cos theta sine theta. Well, sine of theta plus theta is sine of 2 theta equals what? Sine cos plus cos sine. Those are both the same. That's 2 sine theta cos theta. So this is the other double angle identity that I think it's good for you to memorize. There's only one version of this that we use. So if you memorize sine 2 theta is 2 sine theta cos theta, and you memorize cos 2 theta is cos squared theta minus sine squared theta, you'll be well on your way to getting what you need. Let's go ahead and add in the double angle identity for tangent. You don't need to memorize this one. This doesn't come up that often, but I'll share it for you now. Tangent of 2 theta is 2 tan theta over 1 minus tangent squared theta. All right, so that's what we get for our double angle identities for sine, cosine, and here we go, another one for tangent. And the double angle identities are certainly helpful for us to solve various kinds of problems. So let's just take a quick look at a trig equation maybe that we could use this strategy to help us with. So what if I have the following? What if I say cos squared theta minus sine squared theta equals 1/2. And our goal is to find all answers such that 0 is less equal theta is less 2 pi. So that's what we're interested in here. Well, what we can recognize right away is that this is cosine of 2 theta. Now I have cosine of 2 theta is 1/2. I want to introduce a new variable. I'm going to say let W equal 2 theta. So now what do I have? Now I have cosine of W equals 1/2. Well, I need to find out my reference angle. What is my reference angle? We know sine of pi over 6 is 1/2. So the cosine of pi over 3 is 1/2. Sine of 30 is 1/2, so the cos of 60 is 1/2. Remember, cosine means sine of the complement. So my reference angle here is pi over 3. Where is cosine positive? Which quadrants is cosine positive? Cosine is positive where and where? Cosine is positive in quadrant 1 and quadrant 4. So now remember, we're working off of W here. So what is W in quadrant 1? W in quadrant 1 is pi over 3, but let's not forget plus 2 pi k going all the way around. In quadrant 4, what would that be? W is 2 pi minus pi over 3. So coming down this way, coming that way. 2 pi minus pi over 3 is 5 pi over 3. So here W is 5 pi over 3 plus 2 pi k. Well, what is W? W is 2 theta. So 2 theta is pi over 3 plus 2 pi k. Over here, W, which is 2 theta, is 5 pi over 3 plus 2 pi k. If I divide by 2, so dividing by 2 is the same as multiplying by a half. Pi over 3 times a half plus 2 pi k over 2. Over on this side, multiplying by a half is the same as dividing by 2. 5 pi over 3 times a half plus 2 pi k over 2. So what do I get? Where are we at now? We have theta is pi over 6 plus pi k over on this side. I get theta is 5 pi over 6 plus pi k. And I only want the answers between what? Between 0 and 2 pi. So therefore, I have pi over 6 is one of my answers. Pi over 6 plus pi times 1, that's 6 pi over 6 plus 1 pi over 6, 7 pi over 6. Then we have 5 pi over 6 plus another pi over 1, which is 6 pi over 6, which gives me 11 pi over 6. So you'll notice how we use the double angle identity to enable us to solve an equation. We're able to go ahead and do that without too much trouble. Okay, so they're very useful. Double angle identity is certainly very useful. Want to make sure you know them and are able to use them. But where we're going to go next is we're going to develop the half angle identities. So how is this going to work? We're going to use the cosine of 2 theta is cos squared theta minus sine squared theta to develop the half angle identity. So let us do that. We're going to write that down. Double angle for cosine. And I'm going to change it to z instead of theta. Cosine of 2z is cosine squared z minus sine squared z. And I'm going to go back to my Pythagorean identity. Let's remind ourselves of the Pythagorean identity. I'm going to use z here as well. Cosine squared z plus sine squared z equals 1, which tells me then that sine squared z is 1 minus cos squared z. So I'm going to go ahead and I'm going to replace sine squared z with 1 minus cos squared z. So my next move is to say cosine of 2z is cos squared z minus 1 minus cos squared z. Be careful with your signs. Make sure you distribute that negative sign. This becomes -1. That becomes negative, negative. That becomes positive cos squared z. So my next line becomes cos 2z equals cos squared z minus 1 plus cos squared z. Cos squared plus cos squared, 2 cos squared z minus 1. Add 1 to both sides, add 1 to the right side, add 1 to the left side. And what do we get? We get 1 plus cos 2z equals 2 cos squared z. Now let's divide both sides by 2, divide the right side by 2, divide the left side by 2. And again, we are developing our half angle formula here. So I get 1 plus cosine 2z over 2 equals cos squared z. Now I'm going to do a change of variable. I'm going to say let 2z equal theta. I'm going to say let 2z equal theta. That means z is theta divided by 2. So what this becomes is the left-hand side becomes 1 plus cosine theta over 2 equals cos squared z. What is z? That is theta over 2. Take the square root of both sides, but if you do that, you need plus or minus. Don't forget, square root of this side, 1 plus cos theta over 2 equals the square root of that side, cosine squared theta over 2. So I get plus or minus the square root of 1 plus cos theta over 2 equals the cosine of theta over 2. Now, how do you know if it's plus or minus? You have to think about the quadrant. So if theta is in the first quadrant, theta over 2 is in the first quadrant, you would use plus. Okay. If theta is in the fourth quadrant, so that means it's more than 270, half of that is more than 135. So that's certainly going to put you in the second quadrant, in which case it would be negative. So think about what this will be for us to go ahead and determine whether it is a positive number or a negative number. And let me quickly do the same thing for the other version of this. So the other version of this, instead of replacing cosine squared, we replace sine squared. And that will give us a formula for sine theta over 2, if I can. So this time we're going to stick with cos squared z plus sine squared z equals 1. And this time I'm going to solve for cos squared. So I will subtract sine squared from both sides. Minus sine squared z minus sine squared z. So I get cos squared z equals 1 minus sine squared z. Okay. So we can go ahead and we can replace cos squared z with 1 minus sine squared z. There's my identity up on the top of the page here. So I've got cos 2z. So I'm going to start again with cos 2z. Replace cos squared z with 1 minus sine squared z. And then we're subtracting sine squared z again. So I get cos 2z is 1 minus sine squared, 1 minus 2 sine squared z. Add 2 sine squared z to that side. That'll give me 2 sine squared z here. Subtract cos 2z from this side. 1 minus cos 2z. Same as before, let 2z equal theta, which means z is theta over 2. So we get 2 sine squared. Z is theta over 2 equals 1 minus cos 2z, which is theta. Divide both sides by 2. Sine squared theta over 2 is 1 minus cos theta over 2, which looks a lot like the other one. Take the square root of both sides. Sine theta over 2 is plus or minus root 1 minus cos theta over 2. All right. So that's a half angle. So we've developed half angle identities. We've developed double angle identities. Let's list all of those and then use them to solve some problems. So here we go. Double angle identity, cos of 2 theta, cos squared theta minus sine squared theta, sine of 2 theta, 2 sine theta, cos theta. Then we have cosine of theta over 2. Which is plus or minus the square root of 1 plus cos theta over 2. Then we have sine of theta over 2, which is plus or minus 1 minus cos theta over 2, square root. So those are some nice rules for us to keep in mind. Let me ask you to do the following question, and I'd like you to post your answer on the board so we can see if people are with me. So I'm telling you sine of theta is 3/5, and I'm telling you that 0 is less than theta is less than pi over 2. So that would put me in quadrant 1. You need to find cosine theta. What I would like you to find first is I want you to find sine of 2 theta. Can you do that for me? And then B, I want you to find cos of 2 theta. So find both of those and do your best to write the answer on the board with the comments. All right, so I'll give you a minute or so to play with those. See what you can do. If you need some hints, the Pythagorean identity, cos squared plus sine squared is 1, might help you get cos theta. Or you might go sine is y over r and find x, knowing x squared plus y squared is r squared. So let's see if we can get 1 or 2 comments up before I do it. So again, I'll let you guys work on that and see where we get. Okay, I thank Hazem for giving us an answer. Cos is 4. Remember, the cosine's got to be between -1 and 1. So x is 4. X is 4, that is correct, but not cosine. I believe cosine is 4/5. Need some help on that one. Sine of theta is y over r, which is 3/5. X squared plus y squared is r squared. So x squared plus 3 squared is 5 squared. X squared plus 9 is 25. X squared is 16. X is either plus or minus 4, but we're told that we're in the first quadrant. If we're in the first quadrant over here, in the first quadrant somewhere, the x value is positive, so x is positive 4. Cosine of theta is x over r, which would be, what, 4/5. All right, so knowing that, then let's see if we can get sine of 2 theta and cos of 2 theta. So again, I'll give you another minute or so to see if you can write that answer in the comment line. And we'll see if we are together. There's your identity for sine of 2 theta. There's your identity for cos of 2 theta. So Hazem has given us cosine. I've given you cosine. We can have one brave soul write down the value. All right, Hazem is saying 24/15. Let's see if he's right. Sine of 2 theta is 2 sine theta cos theta. The sine of theta is 3/5. The cos of theta is 4/5. So 4 times 3 is 12 times 2 is 24 over 5 times 5 over 25. So close. I like the numerator of 24, but again, we just have to be careful with the denominator. Regarding cos of 2 theta, let me see if someone can write that answer down. Our identity for cos 2 theta is cos squared theta minus sine squared theta. So I'll give it a minute to see if somebody can write that answer. See what we get. Cos 2 theta, cos squared theta minus sine squared theta. Cosine is here, 4/5. Sine is there, 3/5. Who's going to be brave and give me an answer? I know it's tough to be brave when your name is connected to it. Let's see if you can do it. Be brave. All right, well, we have one person participating. That's better than 0. Let's take a look. Cos squared theta. What is cosine? Cosine is 4/5. 4/5 squared minus sine theta, that's what, 3/5. So that gives me 16/25 minus 9/25, which gives me a total of 7/25. So we'll give Hazema an A for the day, a big star for having the right answer. Now I'll take a quick look at the half angle versions of this. So what I'm going to do next is a half angle problem. So same deal where we have sine theta is 3/5 and theta is in quadrant 1. So, I mean, here's the deal. Then where would theta over 2 be? If theta is between 0 and pi over 2, theta over 2 would be between 0 over 2 and pi over 2 divided by 2. So 0 is less than theta over 2 is less than pi over 4, which is still quadrant 1. Well, that's helpful to us because that tells me that sine of theta over 2 will be positive because it's in quadrant number 1. So our usual rule here is what? Sine of theta over 2 is plus or minus, but I'm making it plus. I'm making it plus because we're in quadrant 1 of the square root of 1 minus cos theta over 2, which is plus. So we get 1 minus 4/5 over 2. I expect most of you would solve the problem this way. Plus 5/5 minus 1/5. 4/5 is 1/5. 1/5 divided by 2, which is the square root of 1/5 divided by 2 is times 1/2, which is the square root of 1/10. And same kind of thing for cosine of theta over 2. Again, why? Because we are between 0 and pi over 4. If we're between 0 and pi over 4, both sine and cosine are positive. All right. Let us move on to actually use a half angle. So the next example I'm going to give you, working off the half angle identities, is what is the sine of 22.5 degrees? What is the sine of 22.5 degrees? Again, let me give you a minute to think about it. So I won't make you post because I think we're shy tonight. But take a minute, look at your formula. We've got the formula up here. We've got the value that we need over here. Do you have everything you need to be able to figure out what the sine of 22.5 degrees is? So again, I'll give you a minute to try that. And then we'll take a look at it together. See where we get sine of 22.5 degrees. So you've got to figure out what you're putting in there for theta. I have sine of theta over 2. I want to get 22.5. 22.5 is half of what? 22.5 is half of 45 degrees. So I'm going to replace theta with 45. So sine of 22.5 degrees is the same as the sine of 45 degrees over 2, which is plus because we're in the first quadrant. Theta is 45 degrees. The square root of 1 minus cosine of 45, 1 over root 2, but I think I'm going to use the other version, root 2 over 2, to make that simpler, all divided by 2. Now here comes the challenge. How can we simplify this in such a way that our answer is reasonable? Well, I'm going to multiply top and bottom by 2. Multiply the top by 2, multiply the bottom by 2. That'll make that look a little prettier. Now, again, there's many, many ways to write this. Again, we know this is plus. 2 times 1 is 2. 2 times root 2 over 2 is just root 2, so I get 2 minus root 2 upstairs. 2 times 2, I get 4 downstairs. So an answer for the sine of 22.5 degrees is plus, first quadrant, square root of 2 minus root 2 over 4. All right. And let's go ahead and move on to our next phase, if we can. I want to take a look at the following, and we'll keep those identities close at hand. We're going to have a circle. The circle is x squared plus y squared equals 5. You know, of course, that our usual formula for a circle centered at the origin is x squared plus y squared is r squared. So if that is the case, r squared is 5 and r is the square root of 5. So we know we have the square root of 5 as our radius. Now we're going to go ahead and we're going to draw a version of that circle. And we're going to pick theta here. I don't know what it is, but here is theta. And what we're told is that that point on that circle, the y value is 2 and the x value is a. So it would be nice for us to figure out what that x value is before we try to go ahead and answer some questions. Well, we know, again, x squared plus y squared is r squared. X value here is a, so a squared. Y squared, y is 2 plus 2 squared is r squared is 5. So I get a squared plus 4 is 5. I get a squared is 1. I get a is plus or minus 1, but look at where a is. A is in the second quadrant, which makes a -1. Interesting. Okay. So what do we know about that if we know that a is equal to -1? The x value over r is cosine. Cosine theta is x over r, so it'll be -1 over root 5. Sine of theta will be y over r, so y is 2, so we have 2 over root 5. And then knowing this, we should be able to get sine of 2 theta and cos of 2 theta. So let's quickly do those. Sine of 2 theta is 2 sine theta cos theta. So sine of 2 theta is 2. Sine theta is 2 over root 5. Cos of theta is -1 over root 5. So sine of 2 theta is what? 2 times 2 is 4 times -1 is -4 upstairs. Root 5 times root 5 is 5. So sine of 2 theta is -4 over 5. Cos of 2 theta. Cos of 2 theta would just be what? Would be cos squared theta minus sine squared theta. So let us quickly do that. So again, we have cos theta here. We have sine theta there. Notice if we double this, this is more than 90. So if we double more than 90, that gives us more than 180. So if we're more than 180 and less than 360, the sign is negative. So that's a little mini check that we could do. How about cos of 2 theta? Let's take a look at that. Cos of 2 theta is cos squared theta minus sine squared theta. So cos of 2 theta is what? Cos squared -1 over root 5 squared minus 2 over root 5 squared. -1 is positive 1. Root 5 is 5. Minus 2 is 4. Root 5 is 5. 1/5 minus 4/5 is -3/5. Well, that tells me the quadrant we're going to be in. We're more than 90. Our original thing up here is more than 90 and less than 180. If we double it, more than 180, less than 360. But if cos of 2 theta is negative, that puts me in quadrant 3. So just a note. 2 theta is in quadrant 3. Just to kind of help us do some analysis there. And let's quickly do one of the half angles. So maybe I'll do the cosine this time. So we want to go ahead and do the cosine of theta over 2. So what is that going to look like? Cosine of theta over 2. Plus or minus, but again, notice we're more than 90, less than 180. If we take that half of that, that's more than 45, less than 90. So that puts me in quadrant 1. Hence plus square root 1 plus cos theta over 2. So you got to think about where that's going to be. Cos theta over 2 is plus the square root 1 plus, what is cos theta? -1 over root 5, all divided by 2. That's kind of a mess. Let's multiply top and bottom by root 5. Multiply the top by root 5. Multiply the bottom by root 5. In the radical, And that will give me cosine of theta over 2 is plus the square root. Root 5 times 1 is root 5 minus root 5 times 1 over root 5 is just 1 all over, make sure that's big enough, 2 root 5. And that's a pretty unpleasant looking little answer, but that's the best we're going to get there for us. All right. What else can we do? Well, let's go ahead and try to prove an identity. Let me move this aside. And the identity we're going to look at is the following. We want to prove this. So prove sine of 4 theta equals 4 sine theta cos theta times cosine of 2 theta. Now, normally speaking, we would like to begin with the more complicated side, and there is no doubt that the more complicated side is the right side, but you know something? I'm going to start on the left side instead. And here's my approach. So I'm going to say left side is the sine of 4 theta. Okay. And I want to use my double angle identities. So my double angle identities, I have a double angle identity for sine. So I'm going to rewrite this as sine of 2 times 2 theta. Let me introduce another variable. I'm going to let W equal 2 theta, just so I can understand this a little bit cleaner, make it a little clearer. So this now becomes the sine of 2W, which is what? Well, the sine of 2 theta is 2 sine theta cos theta. That's our basic identity, right? We know that. Our double angle identity, our favorite angle, our favorite double angle identity. Sine of 2 theta is 2 sine theta cos theta. So I can certainly replace theta with W, and I could say sine of 2W is 2 sine W cosine W. That's what I'm going to do. So we're going to make this 2 sine W cosine W. But what is W? W is equal to 2 theta. So I'll replace those W's with 2 theta. So that in turn equals 2 sine 2 theta cos 2 theta. So where does that put us? Well, again, we go back one more time to our favorite identity. Sine of 2 theta is 2 sine theta cos theta. So we can replace this sine of 2 theta with that 2 sine theta cos theta. And what is that going to give us? 2 times sine of 2 theta, 2 sine theta cos theta times cosine 2 theta. And I think that finishes it for us. That will give us 4 sine theta cos theta times cosine 2 theta, which equals our right-hand side, which just finishes up the problem for us. Okay, I think I have time for one more problem to look at. And I want to generate an identity for sine 3 theta. Okay, so we have a double angle identity. I want to construct a triple angle identity. Construct an identity for sine 3 theta. So let's think about that. How am I going to do that? Well, starting with sine 3 theta, that's going to be sine 2 theta plus theta. And we have our rule, right? Sine of A plus B is sine A cos B plus cos A sine B. Let's not forget that, right? Sine of A plus B is sine A cos B plus cos A sine B. A little blurry, sorry about that. I'll take a look. But I'm on autofocus, so I hate to change that now. I'll try to write it a little larger maybe. Okay, so A is 2 theta, B is theta. So I'm going to get sine A, sine 2 theta, cos theta plus cos A, cos 2 theta, sine theta. So using our double angle identity, it gets us there. And then what else do we know? We know sine of 2 theta is 2 sine theta cos theta, multiply that by cos theta, plus, how about cos 2 theta? Well, our favorite version of that, cos squared theta minus sine squared theta times sine theta. And then what is that going to give us? 2 sine theta cos cos, cos squared theta, plus distributing cos squared times sine, cos squared theta times sine theta minus sine squared times sine minus sine cubed theta. And of course, you would never memorize that, right? There's no reason for us to memorize that as we go. So this lesson was on double angle identity and half angle identities. I want you to memorize those. So I'll write it down one more time. Sine of 2 theta is 2 sine theta cos theta. Cos of 2 theta, our favorite version of that, cos squared theta minus sine squared theta, although as we showed, you can actually have 2 more versions of that. And then our half angle identity, right? Sine of theta over 2 plus or minus the square root of 1 minus cos theta over 2. And cosine of theta over 2 plus or minus square root of 1 plus cos theta over 2. So, I mean, these are all very helpful rules for us to use. You saw me proving identities with them. You saw me solving equations with them. You saw me developing a new identity for them. So that's it for this lesson, which brings us to spring break. Enjoy that time. We will have a homework set due when you get back from spring break. I should have that homework set up at some point tomorrow. My advice, as always, is to get that homework done right away. Also, now that you've watched this video, my suggestion is to watch it again. Pause it after I state the questions and see if you can do them. The one problem we have here is it's difficult for me to check on your work, but you need to do that, right? Check on your work as you're going. So watch the video again, pause it, do it, and then check to make sure you're doing it correctly. All right, my friends, enjoy the break. Let's hope the strike is over when we come back so I can see you in person. Have safe travels and all the best.